So in case you face any problem, feel free to do what? To ask me. But after you have tried to solve it by yourself, don't get any problem and just come straight to me. No, because I'm not going to be there forever. And when you start facing real world problems, most of them you will be facing them by yourself. So the best way that I can teach you how to do these things is to teach you how to solve any problem that you'll face by yourself. But I'll not help you every time to solve the problems. So before you come to me, at least try to search like 10 times. When you really fail, then you come to me. But if you fail, still feel free to do that, to come to me. Don't fail and then keep quiet or give up. So that is the way to go. And don't just watch as you practice. Watch as you practice, and that's the best thing. So I'll hope, like, out of 15 people who are already here, I'll assume that all of you, at least you should you must have practiced. You should have practiced what we did in the previous class. If you didn't, then I'll really feel sorry for you, because these things may end up not making sense for you. So with that much said, let's go ahead and start our today's business. I've already shared my screen and I've already set our time. It's going to be 66 minutes, and after that 66 minutes we'll be able to proceed with other businesses. I've opened my I've opened my text editor, which is VS Code, and I believe at this level, when I say VS Code or Visual Studio Code, everyone should be knowing what is meant by Visual Studio Code. I've opened the folder where I'll be saving my .NET programs, which is there, and I believe when I say a folder of that, or where I save my .NET programs, I will believe that everyone should be knowing. Okay, from now start putting your name in the chat so that we can record you as attended this class. Just put your name in the chat. Only the name is enough, only just the name. So there we are. Last time we stopped at loops, and today we said that we are going to look at, what are we going to look at today? Functions. Who can remind me? Can someone remind me what we're going to discuss today? Where we're going to start from today? Anyone who's really following? When you shared the picture, what did you put? Decision making, data types, right?
Decision making, functions.
We'll also look at functions, eh? Okay.
That was part of the list.
Okay, that is great. So Joanne, I hope it's Joanne or Lillian? Lillian, right?
Lillian.
Okay, Lillian, I hope you practiced the previous classes.
I did, though I failed along the way, so I'm still searching how to get past the problem.
That is great. Don't give up. So let's begin the business, right? So what I'm going to do, I'm going to create another file for decision making. So in when you're writing programs, you'll find that most of the time we'll need to make decisions. For example, if you're writing a system that will lead someone to log in, then you'll have to put a decision whether the password that someone entered was correct or not. So that's a decision which should be made there. So almost all programs that will have to make sense will find that we need to make what? To make decisions. So decision making in .NET programming, we use a keyword called if, and those decisions we call them if conditions. And under those decisions, you create a condition, and then if the condition is true, we execute a piece of code, and if it's not true, we either ignore or execute another piece of code. So we have three types of conditions. We have one type of condition called if condition. Three types of condition called if condition. Another one is called if else, and another one is called if else if. So we're going to begin with if else. So I'm going to show you an example of how we can implement if else in our programs. So right click there and say new, and I'm going to put 5_ if condition .dat. Always remember to put the extension. So some of you may be wondering, like, I thought that after 2 classes I'll be able to create buttons and maybe to create something that will appear on the mobile phone, but I'm surprised we are still in black and white. Yeah, other teachers will just take you straight to creating buttons or Flutter and the rest, but that's not the best way of things, because you'll not understand how to do the real programming. So we in Flutter we'll be using that programming language. So it means that if you want to do the good applications of Flutter, if you want to have good foundations, you must first understand these concepts of Dart, or how to write Dart, and then after understanding them, then you can proceed to what? To mobile applications. Yes, we still have like one more class, if this will not be enough, to proceed now to creating what? To create Dart programming. But to create Flutter applications. But when we will proceed to creating Flutter applications, and you have practiced these ones, of course you'll be now confident of what you'll be doing there. Otherwise, if you just proceed to creating buttons and mobile applications without understanding the concepts of programming in Dart, then you'll be mediocre. You'll be just like starting in secondary school before you go through primary school. So that's why I want to give you good foundation in programming, and then you can go ahead and proceed to what? To mobile applications, because no one is chasing us. It is our what? It's our own time. So let us look at if conditions. So to create an if condition, it means that we're going to begin by creating our main function. And when I talk about main function, everyone at this point should be able to understand what is meant by main function. It is a place where our program is going to begin from. So I'm going to do something here. I'm going to create 2 variables. One is going to be an integer. We have not looked at data type, but we'll come to data types and understand these data types. We have integers, strings, and doubles and floats. But right now, just know integers will store an integer number. So I'm going to create a first variable. I'm going to call it int and call it a and put there one value. Let me say 20. I'm going to create another variable int and call it b and put there another value, which is maybe 21. So after doing that, I'm going to do what? I'm going to make a decision and compare if these if one is greater than the other or one is not greater than the other. So let's go ahead and do that. So to write an if condition, or to write an if statement, you write it like this. So we're going to make a decision now. We're going to see how we can make decision in programming. So to make a decision, we do it like this. We just simply write if in that way, and then you open bracket and close it like that, and then you open curly bracket and close it like that. So once you do it like that, it means that we're going to put our condition between these brackets. So here it is where the condition will be between those brackets, normal brackets. The condition will be between these normal brackets, and if that condition is true, anything that we put between this curly bracket will be what? Will be executed. But if it is not true, anything that we put between these curly bracket, it will be ignored. Okay, so let's go ahead and do a condition. So we're going to check if a is less than, so that's how we write less than b. So if you go to the notes that I shared with you, you'll find where we had the operators, and under operators we have what we call conditional operators, relation operators. So those operators, this is the place where they work. So you have one important operator called less than. In fact, this is how I write a comment. A comment is a piece of code that will not execute in your file. So if I do like this, anything that follows that will not execute in what? In my file. So these are the types of operators that we have. So that one, this icon that you see here, this one, we call it less than. It will do something to check if something is less than the other. We have this one we call it greater than. We have another one which is like this. We call it equal to. So this one will check if something is equal to or not. You should not confuse it with the equal sign. This equal sign will change a variable. but this one will compare and check if something is equivalent to each other. So we have equal to. Another one we have greater than or equal to. So this one will check if something is greater than or equal to the other. Another one we have less than or equal to. So it will check if this one is less than or the other. So these are the relation operators that we do what? That we use. And if you go to your notes, you'll be able to do what? To find them there. New members who have just joined, what you do, you just simply put your name in the chat to mark your attendance. Otherwise, if you don't put there, we will count you as absent. So if you have just joined, just put your name in the chat. So these are operators that we use to compare. So what I'm doing here, I've just written if A is less than B. What is A? A is 20. We have assigned 20 in A. What is B? B is 22. So I'm going to check if 20 is less than what? Is less than 22. And if that is true, this thing was going to do what? I mean, everything that is going to be in this between these curly brackets will be executed. So let's go ahead and display something between these curly brackets. So I'm going to simply say print, say what I've just done here. So I'm going to say $A is less than $B, and save. So if I save, I'm going to run this file. So to run the file, I'll simply come here to terminal and create my new terminal. So this is my new terminal. It is there. I'm going to now, you can mute your microphone, Mr. Odek. Okay, so let us run the file. So I believe everyone at this point should be able to run the file. So I'm just going to simply say dot and then give the file name which begins with 5, and then I'll put the tab key to accomplish the file name. Okay, then I press enter. So you can see I've got 20 is less than what? Is less than 22, which is true. So let me try to change this A and make it greater than what? Greater than 22, so that we see if this value will be executed. So I'll just simply put here maybe 24 and save. Let's go ahead and run it. Can you see our program is not showing anything? Let me clean and see. We run, our program is not showing anything. Why? Because this printing is enclosed between this if condition. It will be executed only and only if the value of A is less than the value of B. Otherwise, if the value of A is less than is greater than the value of B, then this one, it means that the condition will be false, and then this part will not be what? Will not be executed. I will come again. I've created an integer and I've stored there 24, which is A. I've created another integer and I stored there 22. Then I check if 24 is less than 22. What do you think? Is 24 really less than 22? Of course, the answer is no, or the answer is false. And once the answer is false, it means that it will not do what? It will not execute this part. Okay. So members, at that point, I hope you are together. So you can go ahead and play with this one and check another condition here. You can write another condition. Maybe I'm going to say if A is greater than what? Greater than B, then I'm going to print that. Print and say A is greater than B. So you can see that this is a different condition and this is a different condition. So one of these will have to do what? To execute, because all of them will be compared, but since they are opposite to the other, you see this one is opposite to this one. So if this one fails, this one will also go ahead and check. So, and the wording is different. So this one will only execute if A is less than B, and this one will only execute if A is greater than what? Greater than B. So if you go ahead and run this, so let us run it. You can see 22, so the value of A is greater than, 24, which is the value of A, is greater than what? Is greater than 22, which is true. So this one was skipped. Can you see? We are having two lines, but only one line was executed. Why? Because it's one line that was true. So if we make these ones equal, maybe this one is 22 and this one is 22, and we don't have a condition that checks if the things are equal. Let's go ahead and run. What should you expect? You're going to expect nothing. Why? Because we are, this 20A is equal to B. So this one is checking, is A less than B? Of course no, it is not less than B, because A is equal to B. So this one won't be executed. Why? The condition is wrong. We go ahead and check, is A greater than B? Of course no. Why? Because A is equal to B. So A is not greater than B. So this one also will not be executed. So we end up having nothing to do what? Nothing to display. Why? Because none of these conditions was satisfied. So let us go ahead and check how to check if things are equal. To check if things are equal, we just simply put if A is equal. So to check if something is equal, you have to put double equal signs. Don't just put like this. If you put a single equal sign, what will be happening? You'll be assigning them. If I do like this, for example, if I do like this, if I just put in a single equal sign, if A equal to B, what does that mean? It means that I am signing A to B. It means that the value of A or the value of B is going to be stored in what? In A. And then that is not comparing. There's a difference between comparing and assigning. So if you want to compare and check if something is equal, you put two double equal signs. So that's how we check. So we'll be checking if A equal to B. So keep it in your minds that there is a difference between comparing and assigning. Assigning, use single equal sign. Comparing, we use double equal signs. So it is just comparing, it is not assigning. So let's go ahead and do what? And print a line here, the relevant line. So you can simply print and say the value of A is equal to the value of B, which is B. So if you run, at least now we have checked all the possible conditions that can happen to what? Integers. If it's not greater than, this will not happen. If it's not this one, this will not happen. And if it's not this one, this one will not happen. Okay? So let's go ahead and run this. If you run it, can you see? You can see this one. You see? 22 is equal to, so this condition was, this bracket was not executed, this one was not executed, but this one was executed. Why? Because it was really what? It was really equal to each other. So I hope you've understood that. Okay? So we'll proceed. Did you understand, members? Oh, some people here. Members, did you understand? Can I confirm from anyone of you? Did you understand the if conditions? Anyone? If you don't understand, still say I do not understand. You're free. Anyone? Unmute and tell us if you understood. No one is confident to unmute. Okay, I will ask Mr. Mukiza Peter. Are you there? Mukiza Peter, can you unmute? Peter, am I alone in class? Adi, are you there? Adijatu. Can anyone unmute the microphone and say something if you're really there? I want to make sure that I'm really in class with people. Oh, it's my microphone that is not working. Let me pick someone. Yusuf. Mr. Bakar Yusuf, are you there? How are you, Mr. Bakar? Bakar?
Yes, sir.
How are you?
We are there. I'm fine, sir.
Are you following?
Yeah, we are following, sir. I'm following.
Did you understand why we need if conditions?
Yes, sir. Yes, sir.
Okay, that is good. Okay, we're going to proceed. Okay, thank you. So let us proceed. So that's how you can mute back. You can mute your microphone. So that's why we need if conditions. We need if conditions to make decision if something is true or not, and then go ahead and run the piece of code. So we proceed.
Mubaraka,
Yes.
I think your mic has some issue, like it's breaking.
My microphone, my network. I think
Like your voice is lagging. It's somehow very low.
really.
Yes, the mic has some harm. The way you can put the pin and doesn't reach is like it has that other
Kind of noise,
sound.
Okay, let me see if I can fix this. So we have looked at if conditions, so we proceed to if else conditions. So I'm going to create another file. It's going to be new file, and I'm going to name it 6 underscore if underscore else, like this, underscore condition dot. So if else condition, it will execute one of the two brackets if the first one is not true. And this is the example how we can use. We can simply say here, let us create our void, our function, our main function, void main, and open bracket and close them, and then we go ahead and create maybe maybe John, variable called John, and in John we store there his gender, his boy. Okay, so we are going to check a condition that's going to check if John is boy or not. So of course this is a Boolean thing. One will either be true or false. So how are we going to do that? We are just going to simply say if John equals to boy. Then you're going to print and say print yes, John is a boy. Okay, so we save that. Okay, so if we run this file, it's going to execute this part, of course. So let's go ahead and run it. And how shall we run it? We just simply say dot and then the name of the file, begin with 6 and press the tab key and press enter. So you see, yes, John is a boy. So this will only execute it if in the variable of John there is a boy there. Otherwise, if we put full stop, what's going to happen? They're going to compare the word boy with full stop with this word that we just put here, and this one will not do what? Will not display. So let us put here just the name of the variable, what is inside the variable. Okay, so here it will be executed if this one is this one. So let us go ahead and run it. You see, nothing is displaying. Why? Because here there is a full stop, and then here we're not putting a full stop. So let's go ahead to implement the else part. So the else part, it will be executed if the first condition is not true. So how do you do that? You just simply attach here the word else and then put the curly bracket and then put there something. So I can simply print and say that the variable that we just compared, which is John, is not what? Is not boy. Let me just put here. It's not boy, is boy. And here is not what? Is not what we are comparing with. What is it? Is the word boy. So here, this condition, let me put your curly bracket. You see, this condition, this first one, this first bracket will only be executed if this condition is true. If it is not true, it will execute the else part here. On part of else, if the second condition will be executed. So one of these one will be executed. That's how we call it if else. So if this is true, it will be executed. If it's not true, it will not be executed. So one of these must be executed. So let us go ahead and run. So if you run it, can you see? A boy with full stop is not a boy without what? Without full stop. So here we are comparing if the variable stored here is this one. Otherwise, if it's not there, then we'll execute this one. If we remove this full stop. So it's going to be, let's run it. Boy is a boy. You see, boy, yes, boy is boy. Here, otherwise here, if we change this one to something else, maybe girl, and run. So what's going to happen? They're going to compare the word girl with boy, and you know girl is not boy. The word girl is not equivalent to boy, so it will execute the else part. Let's go ahead and run that. You can see, no, girl is not boy. You can see that. Okay, so that's how we can compare using if, else, and if. We have different scenarios, like you're comparing the password. Sometimes when maybe people are registering account, let me comment this. To comment a block, we put star and forward slash, and put forward slash and a star. So if you comment something, if I'm not told about comments, but comments means that anything between that this block will not work, will not do anything in our project. So you see, I put there forward slash and a star, and then I put where the comment ends a star and a forward slash. So anything that is green here will not do what? Will not do anything in our project. Right now, if we run this project, it will not display anything. Why? Because we have commented the whole part that had logic. So that's how that's what we call a comment. We use it just to describe something that we don't want to execute in our code. So let's go ahead and do what? And create another scenario. Assume that you've created an application which is going to check if password 1 is equivalent to password 2. So what will you do? What shall we do? We can simply store there password 1. You know, when someone is creating an account, we always ask, please re-enter the password to make sure that this person does not forget the password easily. So you can store these variables. The first one, you store it in password 1. Maybe I enter 1, 2, 3, 4, and the second one, you store it in password what? In password 2. So the only way that will help you to check if these things are equivalent before you allow this person to proceed, the only way is to use if conditions. So that's why we need if conditions. They are really, 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 really important. If conditions are really important. If you did not understand the if condition part, then you have to come back and make sure you get the whole thing. You can as well proceed and understand in future, but it's really important. It's a key of programming. You cannot write a complete program, without including if condition. So let us go ahead and check if these two passwords match or not. How shall we do that? We just simply put if condition and say if password 1 is equivalent. You understand? We remember the thing when I talked about equivalent. We use double equal signs. Don't use single equal sign, because this one will assign the first thing to the second thing. So we're going to say if password 1 is equivalent, by putting double equal signs, is equivalent to password 2. So I'm going to print here, yes, you are good to go. And the else part, I'm going to put here else and say print, oops, passwords did not match. So one of these will be executed, and that's the meaning of else. If the first condition is true, the first bracket will be executed. If it's not true, the second will not be executed. So if you're creating maybe a mobile application that's going to check if passwords are correct, so here you'll take this password to another part. Say, hey, your password did not match in this part. Here you redirect this person to another path. So that's how we need and why we need if conditions. So let's go ahead and run this. What's that? Let's go ahead and run this. So I'll wrap everything and then run the file that and say 6 and then press the tab key, run it. You can see, yes, you're good to go. Why? Because 1, 2, 3, 4 is equivalent to 1, 2, 3, 4. Should we say maybe add here one letter, one number, and we know then they are not equivalent? Let's go ahead and run it. Oh, what's not? Okay, I did a mistake here. Okay, so let's go ahead and run it. these errors will always be there, so you have to read everything in what, in this one, so you can read and still understand what is going on. So let me go ahead and run it. So the first password they're having 1 2 3 4. The second password you're having 1 2 3 4 1. If you run this, can you see? Oops, password did not match. So that's how we write programs, and that's how we make decisions in programming. So that is if else. So we can proceed to if. I'll just simply come here and create another new file. I'm going to call it file number 7 and call it if else if underscore condition dot. So to do that, we are going to write our main function, void main, and then put some stuff here. So if else if, it helps us to chain conditions. For example, you remember this first example. Let me come here to the first example here. You remember one of these had to execute. Why? Because something cannot be equal at the same time be less than, something like that. So we had to do like this. But here the problem that we did here is that we repeated ourselves. For example, if A is less than what? It's less than B. It means that this part will do what? Will execute. But again, we'll find that they're going to again run this one. They're going to compare this. Again, they're going to compare this because this is separate and this part is separate. So even if this condition is true, that will not stop the program. This program will have to stop from here. It means that you'll have to come and execute this one and execute this one. But that's not the best way of doing things. If you have such a scenario, the best way will be that if this first one is correct, then this rest one should be what? Should be ignored. Okay, that's the best way of doing things. So when you have such a scenario, you may need to use if and else if. So that's what you call chaining. Here is when you don't know what you're doing. You're just a beginner. You don't know what's going on. You'll do it like this. Yes, it will work, but it will not be efficient way of doing things because you'll have repeated yourself, and all these things will be running every time you run the program. So if the if condition is taking too much space and time, you'll find that you have repeated yourself and the application is becoming much more slower. Why? Because there are some things which are not necessary that are going to be executed. For example, if A is less than B and we have known it that A is less than B, why should you again check that if A is greater than B? That will not be right. So how can you solve that? You solve that by chaining such conditions. Let's see how we can do that. So I'll copy it all. I'm going to just copy the whole of this thing in if condition and come and paste it here. Okay, and we see how we can chain these ones. So to chain them, we use what we call else. Okay, else if. So I'm going to put here another thing called else if. Else like this. So just simply write else and then followed by if. Okay, so I'm going to also put here another else, and then the remaining thing is just exactly the same. So what is going to happen here? The first thing that is going to happen here is the program is going to check, is A less than B? If this condition is true, this remaining condition will be ignored. They will not be ran again. It will just stop from here because we'll have got the answer. I repeat, it's going to check is A less than B. If this condition is true, the remaining ones will be ignored. The second condition is going to be is A greater than B. If this condition is true, the remaining ones will be ignored. And the last one is going to check if this one is equal to this, and then this one will be executed. So it will begin from top. Once it gets the correct answer, the remaining things will be ignored. So that is the best way of doing things in case you have such a scenario, other than comparing every time like the way we did here. You see? Like the way we did here. So let's go ahead and run this if else if. You see, we call it if else if. Okay, so that's how it is written, and that's how you can implement it. So let's go ahead and run it. So what should we expect? We will expect this last condition to be what? To be executed. Why? Because this one is equivalent to this. So to check Is 22 equal to 22? Of course no. It skips this when it comes to this. Is 22 greater than 22? Of course no. It will skip that one and come to this. Is 22 equal to 22? Of course yes. Then we'll execute this last bracket. Let's go ahead and run this. So I'll simply say dot and say 7. If 7, and then we run that. Can you see? 22 is equal to 22. Otherwise, if I come and change this one and make it maybe 12, so it will execute this first bracket, because 12 is less than what? Is less than b. It will execute only the first bracket and ignore the remaining one. It will not even compare them. It will just stop from here. That's why we need what? That's why we need if, else, if. You can see 12 is less than 22. So we have started creating programs that speaks like human beings. Okay. So I'll share you after the class. Come and play with this if else and make sure that you do what? You understand properly. Search from internet about every topic that we discuss. You can as well learn from other tutors. Don't learn from me only. The best thing you can even learn from other tutors. But just take me as a path. Follow my path. Because if you again go and say, okay, since I can learn from other tutors, let me teach myself. And then after learning if, else, if, you'll ask yourself, what is the next thing that I should do? Then you don't know it. So you find yourself getting lost. So take me as the path, follow my path, but don't learn from me alone. Go and learn also from other tutors. Go and learn from internet about each topic that we touch, so that you should understand everything clearly. And that will be done at an individual basis. Another one will say bullshit and he will not do what I've just advised. Another one will take the advice and go deeper. So one of the two, one will be better than the other. So that is if else part. We can proceed now to decision making. That's all about decision making. I'll share the notes and you can always come and do it. You can always read the notes and understand. So we go to data types. I'm going to be a little bit faster. We go to data types. So data types, these are simple, different types of storage. Of variables that you can deal with in that programming language. We have different types of variables that we can use in that programming language. In the file that I shared with you, they're already there. So we have strings. So string will store a list of characters. We have numbers. So numbers will include, let me demonstrate this to you. I have this file so that you should understand it properly. So we have numbers. Numbers may include integers, doubles. Doubles, they are numbers with full stop, with a point. Numbers with points, and then we have floats. Floats, they are numbers with points. Double, they are bigger numbers, huge numbers, and then we have booleans. Booleans, these are types of variables that can store true or false. And then we have, let me show you the types of variables. Data types, sorry. Different types of data types. I already write about them. I've already written about them. Okay, they are here, right? So these are different data types that we have in that programming language. Numbers. So here under numbers, we have integers, something called integers. We have double. We have float. So an integer is just a number without a decimal point. A double is a huge number, bigger than integer, and a float is a number with a decimal point. We have strings. Strings, these are what? These are characters. Characters, a group of characters. We can store it in a variable called string. You can give examples of variables in string. We may have a name, a sentence, etc. So something that is made by group of characters, we call it what? String. Boolean, something that is either true or false. True or false, we call it Boolean. Then lists, as it sounds, a list is a list of things, is a list of these variables. So if you have is an array, is a group of these previous variables. You can have a list of strings. So a list of strings, it will be a group of so many strings stored in what? In one variable called list. Okay? So a list a list is a data type in that programming language that can store multiple what? Multiple data types. I mean a group of a certain particular data type. So we have maps. Maps, you look at them when you go into Flutter programming, and when we'll talk about something called JSON, we'll look at map. It will store a key and a value. A key and a value. Right now it may not make sense, but when you go to real programming of Flutter application, you'll understand what is meant by what? By maps. So let's go ahead and demonstrate how we can implement these different data types. So I'm going to come here and create another file. I'm going to call it file number 8 underscore data types .dat. So in there, we're going to create now our first void function, which is main function, and we go ahead and create we create the data type. To create an integer, you just simply write int and give this data type a name. Data type is just a variable, okay, that can store a specific type of data. For example, if you create an integer and say age, so this variable will store only age. So I can simply put there 23, and then let's display it by simply saying print and say I am, then you put age like this. That's how you access it, years old. You could do the same thing with variables. With vars, like we are doing this thing, or like you can put here something called var. But var is a lazy way of doing things. Why? Because this var can store anything. But assume that you're going to make a very strict software. Maybe you're going to make a bank application, bank software, and you want to store maybe a pin in a var. So I mean that the hacker will have given a hacker ability even to store a string inside your pin. But assume that the pins of the people's accounts, there will be only integers. So it means that you have to be specific and say this one will be integers. So once it is an integer, it means that if someone tries to enter there, maybe a hacker tries to enter there something that is not integer, the operating system, the software, the programming language itself will not allow that thing to proceed. But if you just simply put var, yes, it will work. But var is vague. It can store anything. It can store even a string. This is how we initialize a string. Can you see? There is no error. It stores a string. Then your application will be vulnerable. Otherwise, if I put here int, it will not allow that laziness of doing things. You see, it is bringing me an error. Why? This one will only store integers, and integers, we initialize them. We don't put quotes around when you're initializing an integer. So I have to put at least 23. This will work. So that's why we need to be specific when defining different data types. So let's go ahead and run this. You can run it by simply writing that, then number 8, and then the tab key. And if you run, you can see we're having I am 23 years old. So it works the same as as variables. Yes, it is a variable as var, but here we are specific that this one should store only numbers. Hope you are together. So let's go ahead and create another thing called string. So string, it can store it can store a string, a group of characters. So if I want to store something like the name, or something like a group of characters, I have to create a string. So if I want to store something like a sentence, I can put here maybe favorite, and initialize it with what? With double quotes. So initializing a string, you have to put double quotes. So initializing an integer, you don't put their quotes, you just put the numbers. So I can say maybe my favorite is mangoes. So I can simply come here and use these two in the same sentence by say I am 8 years old, I'm this years old, and I love my favorite variable. So if I come run this, it will still work. I am 23 years old, I love mangoes. Okay, so it still works, but this is better way of doing things. We have done what? We have specifically defined string as a string and int as int, but still have ability still to do it in a vague way by putting just a var. Still it will work, but it will be a lazy way of doing things. So we have other data types such as we have looked at string. We have another one called double. We have another one called float. We have another one called boolean. So this one will be your assignment. You'll go and try these others by yourself. What is a double? What is a float? What is a boolean? You can try this one by yourself. So those are the data types that we support in what? In that programming language. We support integers, it supports strings, it supports doubles, it supports floats, and what? And booleans. A boolean is something that is either true or false. So go ahead and make more research about this. We proceed. Variables are finished, data types are finished, operators are finished. We go to what? Loops, we finished. Though we looked at only one type of loop, you can go ahead and research about to do while loop and while loop. We don't use them so many times. Okay, so we go to if conditions, we have finished. I will proceed to functions. To lists. Yeah, okay, proceed to lists. The email document to be shared on the email, and no, the documents will be found in the LMS. So if you're registered in the LMS and you can access, you can download all the LMS there. I mean all the documents in the LMS. All the content will be in the learning management system. So you'll find them there in the LMS. All the notes and resources. So let's go ahead and create a list. So I'm going to be a little bit faster here. I'm going to say number 9 underscore lists. Okay, so let's go ahead and create void main. So as I already defined, I said that list is a group of a data type, okay, of a certain data type. So how do you create lists? Just like you can hear, it is lists. So I'm going to create a list of what? Of names of students. So to create a list, you just simply write the word list, okay, and you open this bracket like this, less than sign and greater than sign. We call them square brackets, okay. So you say list and less than sign and greater than sign. Then after here, you specify the data type that you want to store in this list. So I'm going to create a list of what? Of string. Then you put there string. If it is an integer, it's going to be a list of integer. You put integers. If it's double, you put there double. So it's going to be a list of what? Of strings. And now let's go ahead and give this variable a name, because also what? A variable. To give it a name, I can call it maybe students equal to, and then nothing. This is how you initialize. If you want to keep this list empty, nothing. Another way, you can simply put this square bracket, okay, this square bracket. These are called angle bracket, I think. These are square brackets, okay. So inside these brackets, you can begin by defining something. If you want to begin this list with something, you can go ahead and initialize values of this data type in this list, but like this. For example, under students, I have maybe Mizamil, okay, So it means that this is going to be a list with what? Of student, and there's this person inside the student. If you want to initialize it without anything, while it is empty, you just simply do like this. Okay, it will be okay. So let me put another student. I can put Nasir. You see, you just put double quotes and comma, and then another double quote and comma, like that, like that, like that. So if they are integers, then you'll not need, if it's a list of integers, then you'll not need to do what? To put double quotes. You just put the integers inside there. So let us go ahead and create Nomoko, and maybe add more one Betty Appeal, like that. So you can see we have created our list of what? Of students. So how do you access the values inside the list? So to access the value inside the list, you just simply say print, and then say so if you want to print the first student, these values can be accessed through 0, 1, 2, 3. So you can access this one through indices because it is a list, so it is having many things. So if you want to access a specific value, you have to specify the index. Okay, you have to specify the index. So if I want to specify the index of a list in that, it will always begin from 0. So if I want to access this first person, what will I do? I'll have to put the index of the first person, which is 0. So I can simply say student 1 is $ open curly bracket. So if something is going to have, if you want to access something inside the list, you have to put curly bracket, $ and a curly bracket, then $ curly bracket. Now there are so many students, but I want to get a specific student. So after doing that, you have to put here after the name of the variable, which is students, put the square bracket and put the index of the student, and make sure that this index is existing in your in a list. For example, I am sure it has index 0, so I have to put here 0, and then I put a semicolon here. So here it's going to be student 1, and it's going to print for me only this first person in this list. Let's go ahead and run this. Clear the screen. So it's going to be dot 9 lists underscore. Can you see? Student 1 is Mozamil. And but you can see that we have stored all these things in a single variable, but you're able to access only specific student. So if you want to get student 2, then it means that you have to put 1, because after 0 there is 2. So if I do like that, and let me put here maybe student 2, run it, you can see student 2 is Nasir. Now what if I put a wrong variable, a wrong index, maybe 100, but we know in our list we don't have 100 students. So what shall happen? We're going to get what we call run time error. The compiler will compile it, it is okay, but when it is operating, this is going to be an error. Why? Because we're going to try to access 100, yet our list does not even have 100 values. So let's run it. You see, you'll get this Chinese. And when you get an error, don't cry and get worried. Just calm down and read the error, because these guys, they also want you to understand what is going on. So can you see invalid value, not inclusive range from 0 up to 3, 100, and then they will tell you a file which is having a problem, and a place where, and the line that is having a problem, and then you have to go there now on that line, which is line number 4, and access it on line on point 33, and then you'll be able to do what? To solve this problem. But don't be a kind of a person who will see an error and start panicking and start getting worried and start becoming stressed. No, as long as you've chose the programming path, expect errors every day. Every day you try to program. In fact, in programming they say you spend 20% writing code, only 20% of your time writing code, but the remaining 80% is correcting or fixing the errors in the code. So if you have 100 minutes to write a piece of code, you'll only write in 20 minutes, and the remaining 80 minutes it will be you fixing what? Fixing those errors. So if you're a beginner and you're allergic to errors, then this is going to be very hard journey for you. But when you see an error, just calm down and try to solve it. And once you become good at solving errors, then you'll be a good programmer. So you see, this is something that I don't expect, but it has occurred. Why? Because I tried to access something that does not exist in a list. So always fix that problem. Always be ready to fix problems. So in that programming language, this list has got a lot of functions. It's not like C programming language or other languages. It has got a lot of functions that you can use in what? You can use when programming. Just come and search that list functions or methods. So when you click there, and you see many people have written about these things. Many people, can you see W3 whatever? They have written. So it is us who are lazy, or you don't have people who inspire us to come and run. So can you see this when you come and search, you'll find really a lot of information about just a particular topic. So you see I've just searched that functions. So you'll find, for example, this one. This guy has wrote about all the functions that are attached to that list. You see here there are other functions, so many. So if I come and click on this first research result, I can sit down and start learning. You see, so it has a lot of functions. Let me zoom and you can see properly. Among the functions it has, this person would not list them clearly. We have a function called sublist. So this guy will explain what is meant by sublist here. Can you see? He will explain it here very clearly and write enough information that can do what? That can really help you. So when you create a list, then it means that there is something called sublist. And what does a sublist mean? This method returns a new containing elements from an index between the start and the end. So if you want this method to break for you a list, for example, you have a list of 100, but want only things that are between 10 and 20. So you'll have to create a sublist of that, and this is how you create it. And the guy will give you what? An example. So you just need to sit down and start learning, okay? Not wasting time at this age of ours. And you can see the information already there. So if you didn't know the sublist, you'll understand sublist. Shuffle, it is there, also part of list. We have reverse, it is there to do the opposite. Shuffle, to mix the list. We have map, he will also explain. Where type, we have the get range, we have, so there are so many methods. We have every, we have take, we have skip, there are really so many methods that are attached. We have add, we have length, we have is empty. These are most important things that we always use. Add, this one will help us to add a new variable in a list. Length will help us tell us how long is the list. Is empty will help us to check if the list is empty or not. Is not empty, it will help us to check if the list is not empty. First, it will get for you the very first value. Last, it will get you the last value in the list. Clear, it will delete everything in a list. So come and search about these topics and learn. So if I want to get, for example, the last value in the list, what does it mean? So I can simply say last student. So if you want to use the method that are attached to this list or a function, we just write list and then put dot last. So what will happen? It will get for me a PO. So without even doing any logic, it will get for me this last student. If we run it, can you see? The last student is this one. If I want any student, you see, for example, I did not know even any, but I've just learned it from the other guy that there's something called any, and I can use it now. So I just come and put here any. And what will happen, I think it will get for us any student. Maybe. Let's go ahead and run it. Can you see? I don't think any will get for us any student. But you have something called shuffle. Shuffle. You just simply say list.shuffle. So this one will mix for us the arrangement of this student and then give us an arrangement. So let me get the first one So what will happen here? It will dot first or dot last. Let me get the last. Dot first, like that, I think. Yeah. So can you see? What have I done here? I've created my list. I have shuffle. So shuffle, what does shuffle mean? Shuffle will remix these things. Remix randomly. And then after remixing, I get the first one. And then it means that I'll have created a logic that can pick for me any student from this list. For example, if we ask what is going to be displayed in the screen, I don't know. Why? Because it's going to be shuffled. So write that and write, you see, any appear. I run this time, it is appear. I run again, it is Nasir. I run again, it is Nasir again. I run again, so it is appear. So it is mixing them. It is mixing them. That's the meaning of shuffle. So you can always come and search on internet and learn more things. You can even learn more than me and go beyond than me. That's the beauty about the information. You can become better than me if you keep on learning and learning and learning. So that is shuffle. Then the last thing that I would like to show about list is called for each. For loop. A for method. So the for method on list, it will help us. Okay, we'll come to for method. The for method on list, it will help us to loop through lists even without writing the logic of loop. Okay. So to do that, we just simply say students dot for, like this. Okay. So this one will help you to complete the function. But in the extension will help you to complete the function. But in simple terms, you just simply write dot for each, and then you open the brackets like this, and inside that bracket you open another bracket that's going to receive the element, and then open a curly bracket, and then put a semicolon at the last. What is this one going to do? This one is going to loop through all members in that list and be able to access them through this bracket here. So it's going to loop across all lists, and then you'll be able to access those values here. So if you want to display all the people in this list in the console, what shall we do? We just simply write students dot for each, like that, and then put a semicolon there, and then come between this curly bracket, and then simply put a print, and then I'm going to put now the student, and this student, each student, when it loops, it will be giving me that student in this element. So I'll put this student there. Save, come and run. Okay. Our time is up, but I'm going to add more 10 minutes because the voice disturbed us, so that we can finish at least functions. Just 10 minutes. Okay, so we go for 10 minutes. Okay, so I was elaborating that here the for each is going to do what? It's going to get each element, and once you get an element, you can do that, the logic. You want to check if this element is existing, you want to check the balance of this student, you can do that logic inside here. Okay, so I'm printing the logic that I'm doing. I'm just printing inside here. So let's go ahead and run the file. Can you see? We're able to display all students. If you run the file again, so we have another method called sort that is also on what? On list. So you can as well sort. So this is how you can sort something. We run it. You can see we have sorted them in ascending order. We're beginning from A up to the last person. So we have another method that we can add there. It's called .add. So if you want to add something on the list, okay, you want to add something later. To do that, just simply come to that and say .add. Then you'll be able to add there something. Let me add more student. I can add my good student Hadi. I can add another student, Benjamin. I can add another student, Adrian. and can add another student called Flower. So that's how we add. So right now they may not make sense, but when you go to Flutter and start implementing these things, you really enjoy and say, hey, this is how applications are done, and this is how programming language makes sense. But right now they cannot make sense. And don't worry, just pass through the pain, practice everything, research about every topic, understand. In future, in the next 3 classes, you'll now start seeing these things making sense. So let's go ahead and run this file. So we have added more students using the add method on this list. Run it. Boom. You see, they have been sorted. Adrian, Apio, and that's how we loop. It's beautiful, right? So go ahead and learn more about lists. So to finish our today's class, we have 7 minutes. Let's look at what? Let's look at functions, and maybe in the next class we can begin on object-oriented programming in that. So what are functions? Function is a piece of code that we can use to perform a certain piece of task. I repeat, a function is a piece of code or a group of code that we can use to perform a certain specific task. So when you create a function, I don't know how I should even give a real world example. A function is just like the way we see things that we use in real world. We have phones, we have a spoon, you have a cup, you have a chair. So those are like functions. When you want to sit, you'll not get a phone. You'll go to what? You'll go to a chair. When you want to eat, you'll call what? A spoon, and then you use a spoon to eat. When you want to sleep, you'll go to the bed. So everything, every property that is surrounding you right now, it is like a function. So in programming, we have things called functions. They will perform specific tasks. First of all, you first define a function. After defining it, then you then call it. So when you're defining a function, you're just like buying, or when you're creating a function, you're just like buying something. When you create a function, you're like, I'm buying a car. So when you buy a car will be there. When you want to ride, you call a car you go to a car, and then you can go ahead and do what? And ride. Likewise, when you define a function will be there. If you don't use it, it will be there waiting. It will not be implemented. If you want to use it, you simply call it. So those are the 2 steps. Just like though we do things in real world. You first buy something and it be there. If you don't use it, it will be there. If you don't use a spoon, it will always be there. But when you want to use it, you get it and use it. Likewise, in programming language, we can define functions. If you don't call them, they will be there. After defining them, you can call them. So when you call them, those pieces of code that is inside that function, they'll be executed. So how is it done? Let's go into the practicals and see how we can implement different functions. So you're going to go ahead and create a function that is going to add 2 numbers. So I'll simply come here and create another another file, number 10 underscore functions dot add. Okay, so to create a function, you remember we even had one function called main function, right? So let us begin by creating our own function, not the main function this time. So to create a function, first of all, you first tell what is promising or what is going to do, what it will bring back. When you're buying a phone, it has things that it promises you. It will promise you that, hey, if you buy me, you'll be able to call another person, you'll be able to browse internet, you'll be able to do A, B, C, D. So that is what you're expecting from a phone. But if you buy a phone, you don't expect it to give you food. But if you buy maybe food, then you expect something like food from food, right? I don't know whether you're getting something. When you buy something, you're expecting something from it. You cannot buy a computer and expect that computer maybe to give you water. No. There are things that you expect from what? From a computer. When you buy a bottle of water or a bottle of soda, then you expect some liquid of soda inside that soda. So likewise, when you're defining a function, you must begin with something that you're going to expect from this function. Like we said, you're going to create a function that is going to add 2 numbers. So it means that you have to do what? to expect an integer from this function. So we begin with what we expect. So I'm going to say integer, and I'm going to give this function a name, add, and then we do like this. So you see this function is still making complaint, still complaining. Why? Because we promised that we will return an integer and we have not returned it. So let us go ahead and create here inside this function. So this is how we define a function, and inside this function you can create a variable. So I'm going to create a variable called answer. It's going to be an integer called answer, like this. Okay, and this answer is going to be 0. So after creating this answer, I'm going to make sure that I return what I promised. You see here, I promised that I'll return an integer, so I have to return what I promised by simply saying return answer. And you know the answer is a what? Is an integer. So there's no more complaints. Now everything is beautiful. So this function will have something called arguments. There are functions which don't have arguments, but according to the I know I'm very fast, but I know you'll connect the dots and understand at this point. So the function will have argument. It will take things. For example, an addition function. There are some functions which don't need arguments. For example, a function that will just display a name that's already existing. So this function must have an argument, and an argument is something that we will pass to this function for it to be able to accomplish. When you're going to cook food, you need a saucepan, but there are some things that you must put in a saucepan in order this saucepan to make for you food. Otherwise, if you don't put those things in a saucepan, then it will not make for you food. So for example, if you need to cook food, you need a saucepan, which is a function, and you will have to add there maybe cassava and cooking oil and then it will be able to make for you food. Likewise here, this is a function. For it to perform the addition, we must give it what it should add. So how do we give it, or how this function will receive? We just simply put here the variables here between these brackets. So this function will expect two variables, int a, comma, and int b. The naming is, you can use anything that you want. You can use anything to name it. So it's going to expect two integers, an integer a and an integer b. So once it gets these two integers, it's going to add them up and then return us the answer. And how can we get the answer? We just simply say answer equals to a plus b. So after getting the answer, it returns us the answer. So you can see how they are related. So to call this function, we must give it two things. We must give it the first value and the second value. And then after, it will do the whole logic and give us the what? Gives us the answer. So let's go ahead and now create our main function. This function, if you run this program, it will not do anything. Why? It does not have a main function. It does not have a heart. So the heart of that program is the main function. It is where the program always begin from. So we create our main function, void main, and open bracket and close, and then curly brackets like that. So let's go ahead and time is up. We'll start from there in the next class. Thank you for being part of this class up this point. We will begin from there in the next class. Make sure that you put your name in the chat. So we'll share the video after this class, and we'll also share the material and the tasks. About the follow-up. First of all, you the one who have to make your own follow-up. Make your own follow-up, because I'm dealing with many things. So I cannot manage to follow up on each and every 70 students that I have. So begin making follow-up on your own. I believe all of us were here mature. So begin by making your own follow-up. Otherwise, if you wait for me to remind you to practice, if you wait for me to remind you to do your task, then you may be disappointed really. That since you have sacrificed to give your time to learn these things, then don't let them go. For example, if you did not practice the previous class, then this class you may be confused. So sit down, remind your own self, and make follow-up. If you find problems and you really search, you have not solved it, then come to my inbox. I'll be able to help you. Otherwise, if you don't help yourself, then the whole thing will not make sense to you. So make follow up by your own self, make a follow up by yourself, and then after, when you're really stuck, then come to me. I can help you. I'll also try to make follow up. For example, I'm planning that on every Sunday, since we don't have a class, every Sunday I'll be meeting around 10 students, and we do one-on-one discussion. So I I pick 10 students on a certain Sunday during the class time in the evening. I get each student and we discuss one person to person where you're getting problems and how you can solve these problems in programming. One person, and another weekend, another person, another weekend, another person. That's how we're going to do it on each Sunday. But the whole thing will just come back to you. You have to make your own follow-up. Make sure that you put everything together by your own self. When you're really stuck, then come to me. It is just like self-service. The food is there, the